Chapter 8, Exercise 8.87. The density of a 17.0% by mass ethylene glycol solution in water is 1.04 gram per milliliter. Find the molarity of the solution. The molarity is equal to the number of moles of solute divided by the volume of the solution in liters. We do not have the number of moles of the solute, and we do not have the volume of the solution. So how do we tackle this problem? Well, I think the simplest way of tackling this kind of problem is to assume 100 grams of the solution. Why? Because if we have 100 grams of the solution, there's 17.0% by mass. We get the number of grams of the solute immediately. It's 17 grams out of 100 grams of solution. What about the volume? Well, we have the density, we have the mass, 100 grams divided by the density, we get the volume in milliliters. So let's tackle this problem. Again, we're assume there is 100 gram of such solution, and then 17 grams of ethylene glycol, which is, we have 2 carbon, we have 6 hydrogen, and we have 2 oxygen atoms. Alright, so you can see the molecular formula. C2H6O2 has a molar mass of 62 grams per mole, and we're assuming 17 grams of such chemical in 100 grams of solution. Now we have the number of moles, which is 17 over 62, and then divided by volume. How do we get the volume? We assumed 100 grams of the solution, the mass over the density. Over here the density is 1.04. So after you dissolve ethylene glycol in water, it increases the density value to 1.04. Alright, now there's one more thing we need to do. 100 grams over 1.04 gram per milliliter. Whatever we have here is in milliliter, not in liter. So now it's good, and I think the answer is given here. It's 2.85. So what I'm gonna do is I'm gonna just enter 2.85 here, and it should be just correct. Alright, let's see how Mastering Chemistry tackles the problem. I guess they also assumed the mass of the solution is 100 grams. Well, you don't have to do that. You can assume the mass of the solution is 1000 grams. That's fine. You'll get the same concentration in the end. Or you can assume 1 gram of the solution. It does not matter. Both the concentration and the mass percentage and the density are so-called intensive properties. They do not depend on the amount of the chemical. But anyways, let's get back to here. If you assume the mass of the solution is 100 grams, it's really easy to get the mass of the solute, 17 grams. And then we have the molar mass, 62. We calculate the number of moles of this ethylene glycol, which is the solute in the solution. What about the volume of the solution? Well, it's just the mass over the density, and finally we convert milliliters to liters. And finally, the equation for molarity is the number of moles of solute divided by the number of liters of solution. We get 2.85.